When people imagine Bitcoin mining, they often think of a few computers running in a basement. In reality, modern Bitcoin mining happens in purpose-built facilities, industrial spaces designed to move massive amounts of electricity, air, and data as efficiently as possible. These facilities are not just buildings, they are carefully engineered systems where layout directly determines profitability. At its core, every mining facility follows the same basic layout. Facilities typically use large, open warehouse-type spaces, often pre-engineered metal buildings, to allow for flexible and high-density layouts. Power enters the building, flows to rows of mining machines, heat is removed, and data moves in and out of the network. The most common airflow design for small to medium operations is a wind tunnel approach, where large exhaust fans create negative pressure, pulling cool air in from one side of the building and pushing hot air out the other. Wiring often runs in conduits or is arranged with robust cable management systems. The challenge is arranging these elements so energy isn't wasted and machines can run non-stop. Designs often incorporate modular construction concepts, allowing for phased expansion to optimize capital expenditure and adapt to evolving hardware. Shipping containers are also used for portable, modular solutions. Even small inefficiencies, poor airflow, long cable runs, or uneven cooling can turn profitable mining into a loss. Effective rack and row design for Bitcoin mining focuses on maximizing cooling efficiency and power distribution while ensuring accessibility and safety. Mining machines are usually installed on metal racks, stacked in long, uniform rows. This layout keeps wiring simple, airflow predictable, and maintenance fast. Most miners pull cool air from the front and eject hot air out the back. That means row orientation matters. Every rack must align with the cooling system, or heat builds up quickly. Ensure adequate space between rows and around individual racks for easy access during maintenance, upgrades, and cable management. Bitcoin mining operations have very high power densities, often exceeding 150 kW per rack in industrial settings. For high-density operations, liquid cooling, direct-to-chip or immersion, is more efficient, quieter, and allows for more compact layouts. Facilities commonly range from 1 MW, powering 300 to 900 miners, to large-scale operations consuming 200 MW. An efficient power usage effectiveness (PUE) for a mining farm is considered to be between 1.1 and 1.3. This means that for every 1.1 to 1.3 units of electricity consumed by the entire facility, 1 unit goes directly to the mining equipment. One of the most common layouts is the hot aisle, cold aisle design. Cold air is delivered into specific aisles, while hot air is pushed out through separate paths. Keeping these airstreams separated prevents machines from recycling their own heat. This simple layout decision can dramatically improve efficiency and extend hardware lifespan. This separation is crucial for cooling efficiency, with physical barriers, like insulation panels or containment systems, used to prevent the mixing of hot and cold air. The airflow volume required for exhaust must equal the sum of the airflow from all miners in the facility. The cold aisle should maintain an air temperature between 18 Celsius and 27 Celsius. Hot exhaust air from ASICs typically ranges from 55 Celsius to 80 Celsius. Recommended intake velocity at louvers is between 500 to 800 fpm. Exceeding 1000 fpm can increase static pressure and energy costs. Recommended aisle widths are at least 1.2 meters. Hot aisle containment can improve power usage effectiveness (PUE) by 10% to 30%, moving facilities closer to an ideal PUE of 1.0. Power is the lifeblood of a mining farm. High-voltage power lines supply the power to local substations. Then power is allocated to transformers which step down the voltage. Next, power distribution units feed each row of server racks in a Bitcoin mining facility. The farm connects to a high-capacity utility line, often using a dedicated transformer provided by a supplier like Raptor Power Systems to handle multi-megawatt needs. Electricity enters the facility at high voltage and is distributed through power distribution units to each rack. Commercial mining operations overwhelmingly prefer a symmetrical three-phase power supply, e.g., 380 volts or 415 volts to 480 volts, for rack power. as it allows for better load balancing and saves on cable investment compared to 220-volt single-phase systems. High amperage PDUs, like 335 amp at 415-volt input, are used within the racks to deliver power directly to the miners. To ensure an efficient and stable system, the number of mining machines on each rack layer should ideally be a multiple of 3 to balance the current across the 3 phases. A single large farm can consume as much power as a small town. Real-time monitoring of power usage and system performance helps manage energy costs and prevent downtime. Layout matters here. Shorter cable runs reduce losses, and balanced loads prevent failures. Momentary interruption protection. UPS systems, with battery runtimes typically sized for 10 to 20 minutes, protect against brief power failures, voltage sags, and surges. These short interruptions happen frequently in industrial power grids and can cause wear and tear on expensive ASIC miners. Off-grid farms using solar or wind power rely on large battery banks as their primary storage solution to bridge nighttime or cloudy periods. Poor power design can shut down an entire operation in seconds. Every watt of electricity a miner uses becomes heat. Without proper cooling, mining hardware would destroy itself. Most facilities use directional airflow, pulling cool air in, pushing hot air out. Powerful industrial exhaust fans located at the end of the hot aisles or throughout the facility push the hot air outside the building. This creates negative pressure that continuously draws in fresh cool air. Air cooling is easy to start with. 1 or 2 miners in a room with fans and some open windows might be enough. But as you grow, cooling multiple machines with just air becomes harder. Fans lose their effectiveness when there are too many miners heating the same room. In large setups, air cooling may also involve extra ventilation systems, ducts, and exhaust fans to handle heat from multiple machines. Each machine has high-speed fans that sound like a hairdryer or even more deafening. If you have a few miners running at once, the noise can be overwhelming. Most air-cooled units, such as the Antminer S21XP, are rated for ambient temperatures between -20 degrees Celsius and 40 Celsius. Recommended intake temperatures are about 15 to 35 degrees Celsius for an optimal chip temperature below 80 Celsius. Some advanced farms use immersion cooling, where miners are submerged in special liquid to absorb heat more efficiently. Hydro cooling requires a bigger investment. You need hydro-compatible miners, coolant, a circulation pump, water blocks, radiators, and pipes. Some large-scale farms even installed chillers to keep water extra cold. Even though hydro systems cost more in the beginning, they can save you money over time. Why? Because your miners stay cooler and run longer. You avoid overheating-related breakdowns. You don't need to run power-hungry fans or air conditioners 24/7. You may even mine more coins since your machines won't throttle down due to heat. Though hydro cooling isn't as simple as air cooling, it's becoming the smarter option for farms and long-term miners who want better performance and less downtime. Cooling layout is one of the biggest cost and performance factors in mining. Mining facilities also require robust networking. Each miner connects to switches, routers, and monitoring systems. Mining doesn't consume large amounts of data, with typical transfer rates being very low. However, consistent uptime is crucial. Even brief disconnections can lead to lost mining shares and reduced efficiency. Ethernet connections are universally preferred over Wi-Fi for stability and reliability. Many farm operators implement backup internet connections or failover mechanisms. Network performance and individual miner status are constantly monitored through software and management dashboards to ensure optimal performance. Operators track hash rate, temperatures, power usage, and error rates in real time. A good layout separates networking equipment from heat-heavy zones and ensures constant connectivity to mining pools. As facilities grow, layout becomes about risk management. Bitcoin mining farm redundancy and risk management are crucial for ensuring operational continuity and financial sustainability in a highly competitive and volatile industry. Effective strategies cover operational, financial, hardware, and energy risks. Operators divide farms into zones to isolate failures. Backup generators, redundant power feeds, and fire suppression systems protect millions of dollars in equipment. Other important considerations miners must take into account are internet connectivity, environmental controls, physical security, geographic distribution, cost management, maintenance, regulations, insurance. Maintaining a sound financial strategy involves ensuring sufficient liquidity to cover operational expenses, electricity, debt payments, salaries, even if Bitcoin prices drop. The goal isn't perfection, it's resilience. A well-designed layout keeps mining even when parts of the system fail. Two mining farms can use the same machines and the same electricity, yet one makes money while the other fails. The difference is layout. Mining facilities are often in remote locations, requiring robust physical security measures to protect valuable equipment. Continuously working to lower production costs, particularly electricity expenses, is a key competitive advantage and risk mitigation strategy. Efficient power flow, cooling design, maintenance access, and redundancy determine whether a mining operation survives long-term. Setting up a successful mining farm in 2026 requires meticulous planning across legal, financial, and operational aspects. This can be divided into 3 phases. Phase 1 is planning and feasibility analysis. Analyze the current market to select the most profitable and accessible cryptocurrency to mine. Factor in network difficulty and potential future growth. Research and comply with all local, state, and national laws. Seek legal counsel to ensure adherence to tax obligations and environmental standards. Choose a location that offers low industrial electricity rates. Determine initial capital expenditures (CapEx) for hardware, infrastructure, cooling systems, and installation, as well as operational expenses (OpEx) like electricity, maintenance, and labor. Phase 2 is infrastructure and equipment setup. Investing in high-efficiency, specialized ASIC miners with low joules per terahash ratings. Install dedicated industrial-grade electrical infrastructure, including transformers, distribution panels, and surge protectors, to handle the high and stable power demands. Implement robust cooling solutions, such as industrial air conditioning or more advanced liquid immersion cooling systems. Set up a stable, high-speed internet connection and robust network security measures, including firewalls, to protect against cyber threats. Phase 3 is software and operations. Install compatible mining software and an operating system on the mining hardware. Join a reputable mining pool to combine hashing power with other miners. Configure a secure cryptocurrency wallet to receive and store mined rewards. Regularly monitor the farm's performance, temperature, and power consumption using web-based dashboards. Continuously optimize software settings and explore options to scale operations by adding more miners or upgrading infrastructure. Bitcoin mining isn't just about machines, it's about careful planning, infrastructure, and efficient operation. If you want clear, no-hype explanations of Bitcoin mining, subscribe to Bitcoin Mining World. We break down the machines, the infrastructure, the economics, and latest news powering the network.